Hello and welcome back to one of the first real lessons in this tutorial series. In this video we're going to be discussing uh, different ways of handling information, particularly storing information, and what that looks like in Java. So coding is all about three things: storing, modifying, and sharing information. And the first of these that we're going to look at is this idea and importance of storing information. So a good example of this idea of storing information is the simple calculator program that can add, subtract, multiply, and divide. But the catch here is that it can only do this between two numbers. So what happens when our calculator needs to compute a larger equation, such as this equation down here that just says 3 times 2 plus 5. And so what needs to happen is that the calculator first needs to do the first computation, the 3 times 2, and it needs to store that result in memory. And once that result is stored in memory, you now have two numbers that you can do a calculation between. And so now we can do the addition and we get our final answer of 11. And so this is a very, very simple example. It shows the very basic idea and importance of how we need to store information in our programs to make just about every single thing work. Expanding even further into this idea of storing information, what we can do is we can actually break up what information we're storing into three categories. And believe it or not, with these three categories, we can represent just about any piece of information. And so those three categories are numbers, words, and these things called booleans, but we'll get to that in a little bit. So the first thing that we're going to look at is the numbers category, and broken down into three kind of basic data types. We have the first one being integers. And so integers represent your whole number or your counting numbers, for example, 1, 2, 3, 4, etc. This also includes negative numbers as well as the number 0. But you also have two other basic types of numbers, which are floats and doubles. And these are essentially the same thing. These both represent all of your decimal numbers. These can also be negatives and include the number 0. But you may see floats occasionally throughout your coding experience. But in robotics, we usually just use doubles. And the reason that they're different is because floats actually use up less memory. They're just less precise, and as you can see here, they store less information than doubles. But for the use of FRC, we don't have those memory constraints, so we can use those larger numbers, and as a result, we just use doubles everywhere. But it's kind of handy to know that floats exist. You'll see them at some point, but for the most part, it's just doubles. The next category we have that can represent information we can store are words. The first subcategory are characters. This would be anything that you see on your keyboard, including the character A, the question mark, a period, anything that you can type on your keyboard. Any of those characters are, well, characters. So then we have strings, and strings represent any combination of characters. This can be a word, a sentence, a paragraph. It can be any combination without any limit to length. The last type of data that we can store is something called a Boolean. So you probably haven't heard of a Boolean if you're new to programming, but what Booleans represent are this idea of something being in one of two states. It either is or it is not. And so that's where you get this idea of true or false. And so an example of this would be, is a lamp on or is it off? Are you running or are you not running? Is a wall white or is it not white? If you can split it up into these two distinct categories, then you can kind of represent certain information as booleans. All right, so now that we've taken a look at how to store information and the importance of storing information, why don't we actually take a look at how to do this in Java? So if you hop over to the lesson GitHub page over here, and you go to folder 1 or lesson 1, and then go find this main file, you should see something that looks just about like this, where you have this main method in here, and this class made and package lesson1, all that. And what I want you to do is I want you to ignore all of this and only focus on this white space between these two curly braces here. So you can just add a bunch of space here. And so for now, we're going to learn about all this stuff around it. But for now, just to show you some of the stuff that we've learned, um, we're just going to tunnel vision here and look at how to create variables and store information in Java. So in Java, the formula here for storing information is basically this idea that what we do is we have to declare kind of this type of container that we want to store information. So you have I kind of think of it as kind of like a cardboard box, and this cardboard box has some type of shape or some shape that can only store certain kinds of information. So you could kind of think of like a circular cardboard box should only hold circular stuff, or a rectangular box should generally only hold rectangular stuff. That's kind of how I like to think of it. And then on the outside of that cardboard box, you have this label. So if you had like a giant like warehouse of containers, and you were like, "Where is my box?" Instead of having to open up each box individually, what you can do is we can place a label on each of these boxes so that we can really easily find this information that we've stored. The last piece of important information that we have here is the value that we want to put into our box. So what it ultimately looks like is we list the type of information that we're storing in the box. We have a label so that we can easily find the box. And then there's this equal signs, which basically just tells Java, hey, I want to put our desired item that we're storing in our container, I want to put that into this container here. And that's what that equal sign does. Sorry. And then over here we just have a semicolon at the end. In Java, it's the equivalent of having a period at the end of a sentence in English. It just follows every statement that we make. So where a sentence in English ends with a period, a statement in Java ends with a semicolon. So taking a look at what this might look like, as I said, oops, Alt3, there we go. As I said, you have to specify what kind of information you want, the type of container, or the better word for it is data type, but we have to specify the data type for our container. Oops, I'm on the wrong file over here. So if I type in, these are all data types, by the way, that you can use in Java. And so I'm just going to kind of go down this list here and kind of explain how all of this works. So with the first data type, we have integers. And so if we go back over here and looking at kind of this formula, the alternate formula, which more follows the words you'll commonly see or commonly hear when talking about code or Java, are data types, variable names, and values. These are the equivalents of like the type of the container, the label for it, and then the value stored inside of it. But what we need here is, oops, there we go, my mouse is a little stuck there. What we need here is the type of information we're storing, which in this case is an integer. Then we need to give it our container a label. So we're going to call it an integer. Oops, integer. And then what we need to do is we need to use this equal signs here to store a value, in this case the value 5, to store that value inside of our container. And I have to put the semicolon at the end. And now you'll see that pretty much Java's happy. Java will sometimes give you these yellow squiggly lines, which are suggestions to things you could change about your code, or potential problems that might be an issue down the line. But the actual problems you'll come to see are when you don't have, or when you have like this red squiggly line underneath. This is when your code just simply won't work because it's an error that Java will force you to fix. But if our statement is correct here, we don't get any of those red squiggly lines. Everything works here. And so essentially what this does when we run this program is Java creates this container that stores integers, is labeled an integer, and stores the value 5. All right. So, to kind of prove the things that we've seen here, or to kind of show you that this is exactly what Java is doing, I'm going to introduce you to something called a print statement. And so in Java, what we can do is we can print out information from inside of a program using something called system.out.print. So system, uh, also be careful because Java does care about capitalization, and in this case system is capitalized, and that's the only word in it that is capitalized, but that's the only letter. The S in system is the only letter that is capitalized in here. Um, but if you type it out, system.out.println, and so what I'm going to print out is whatever is inside of these two parentheses here. And so anything that gets stored in here will be printed out to our screen. I can actually just prove that to you with a simple statement. Um, Going or fast forwarding a little bit to the string, the type of string information. If you surround stuff in double quotation marks, that's how you create those strings or sentences. So I can put anything in between this, and this will just be read off as a sentence by Java. So I can type out hello world, and put an exclamation mark. I can put any combination in here. It's fine as long as it's still in the quotation marks. But this will just be read off as a sentence by Java. And so if I print this out, you'll notice that, oh, it just prints up hello world. Does exactly what we want it to, and just prints out whatever is inside of these parentheses. But what if instead what we do is we print out our container that we created here just a little bit ago? And so if I put the label of our container, um, what you might expect is, oh, I just showed you if I put in hello world in here, it's going to print out exactly what was in those parentheses. But what Java actually does is it's a little bit smarter about it. And so if I run the program, you'll see that it actually prints out the value 5. And so what is going on over here is that Java, or in general, like in real life, if you have a cardboard box, you generally don't care about the cardboard box itself. What you care about is the information inside of it. And so when I'm telling Java to print out our cardboard box here, or our integer container, um, what it's doing is it's basically skipping a step and simplifying things, and actually reaching inside of our box and pulling out the value that we stored in there. And so the great part about this is it makes storing information really easy, and we can actually do a lot of complicated logic using this idea of containers as like storage systems for holding onto information. So, because it pulls out the value that we stored in there, remember that the equal sign puts the value we put here on the right into our integer container named an integer. Java is just pulling that value back out of the box and printing it out here in this statement right here. So what this looks like for all the other data types that we had over here, if I go like this and come back over here. For our other data types, we have things like floats. And so float, I have to give it the name of the container that's holding a float. So we'll call it my pi as float. And then I'll put the value 3.14. And this is where Java is a little weird. Makes you put an F at the end for floats. Once again, actually, floats aren't that important, and they're not something you'll see very often in FRC programming, but they are very useful, or they do exist out there in the wild, and so you'll maybe see them, and it's just kind of helpful to kind of know that they exist. But what we could also do is we could create a double and create a container labeled my double, my pi as double, and then I can store the value 3.14159 in there. And so once again, it does the same thing as it did with an integer up here, where it creates um, a a box that stores doubles and has a label on the front labeled my pi is double, and we put this value of 3.14159 in our box labeled my pi is double, and now we can easily access this information over here by the label of the container, which is way easier to work with when you're programming. If you had to rewrite out uh, all of the numbers for the information stored in these containers, every time you want to do some computation, not only would it take really long to program that, but what this also lets you do is it lets you easily change the values and change how like a calculation is carried out, but it doesn't change like the formula for it. And we'll see that in future lessons, but that's just kind of a snippet into why we do something like this. So, um, then if we just print out this information here, system.out.println, what you just saw me do there was if you don't want to have to type out this whole string here every time, if you type out capital S and then type out system, you can either go down to it with your arrow keys here and easily select things, or you can select it with and then press enter, or you can press it with left click on your mouse, and you could easily type it out. So you don't have to type it out every time. It kind of gets tedious. You might start doing it, you might not. Up to you. It's just a preference thing. But we can print out these values that we just created. So my pi is float, and then I can also print out my pi as double. Oops, I forgot to add the print statement. System.out.println, and then my pi as double. You'll also notice that there is a print or println, and actually there's also a print statement if you pay attention to that autofill thing that was showing up earlier. What that just means is if you add the ln on the end, it just when it prints out new information in the terminal down here, uh, when it prints out to a new line, or it the at the end of it it'll print a new line. And so if I print this out here, what you'll see here is it'll actually print out to the same line, 3.14 and then 3.14159, and that by adding an ln to the end of that statement, when this is done getting printed out, it'll add another line right after it, so information doesn't get like too like cluttered there in the terminal. But so those are our numbers, and then we can also do things with um, words and booleans. So real quickly, what that looks like is we create a character container named my character. We can label these anything we want. There are generally better names for variables. You do still have to be able to easily read code. And so you want to be very intentional with the names you give things and the information that's stored inside of them. But they can technically be named anything as long as you use the same label throughout your program. So create a character container called myCharacterContainer, and then we assign a value. And for characters, you use a single, or not a quotation, an apostrophe here, and then you put the character you want inside of there, and then you add your semicolon at the end. Java's happy. System.out.println, and then we can print out our character container, and it should just print out the letter A. We can replace this value with a quotation mark, or just, once again, any value that you have on your keyboard. Strings are just combinations of these characters and can be pretty much any length. One thing to be careful of is, once again, capitalization is important, and strings are more complicated than these other types of information. And so there's a lot of stuff that goes on in the background and stuff we'll learn more about later. But for now, we can treat them pretty much the same. But in this case, you need to use a capital S for strings. So with a string, we're going to create a container that stores strings, give it a name, my string container. Oops. And then you have to use double quotation marks. And then I can put pretty much any combination of characters in there, and Java's perfectly happy if I ask it to print it out. Oops, I forgot to print it out. So system.out.print, and then my string container, and I click run, and it'll just print out whatever's in these quotation marks here. One thing to be careful of, one thing to be careful of is that containers are very specific about the type of information you can store in them. Notice here how we're telling our container, hey, we can only store strings in this container. What that means is we cannot store any other type of information. So if I try to store a number in here directly as a number, like 3.14, you'll notice that Java is not happy because you can't convert from a double to a string. And you can technically represent this information um, as a string here, but you have to put it in quotation marks. And by putting it in quotation marks, putting a number in quotation marks, it removes a lot of your ability to be able to do things like certain math calculations that you'd normally be able to do with numbers. But you essentially you just have to store the right type of data in those cardboard boxes or whatever is storing your information. All right, and then so the last thing, booleans. So booleans boolean, my boolean container equals, and in this case for the value you store in a booleans or in booleans are true, and then you can put a semicolon or false. These are both acceptable values that you can store in a boolean. And the point of this is when you're doing a lot of logic, say I had like an app that was keeping track of whether it was raining or something like that. I had create a variable labeled is it raining, and so instead of having some like abstract value, by naming it something very logical and printing out the value here, I can easily keep track of the information that's being stored in there, and I can very easily do logic with those booleans, and it'll eventually come in very handy when we get to things like if statements, where you can have certain parts of your code run if something is true, and then other parts if it's false. So if it's raining, maybe you wanted to print out whether or not you need an umbrella. Otherwise, like put on sunscreen or something simple like that. But it's an important part of logic that we'll need to become familiar with as time goes on. So if I print out the container labeled "Is it raining?" And I run it, it'll just print out the value false. All right. So then there is one last thing here that I want to elaborate on, and this is this idea of um, declaring, assignment, and initialization. These are all vocab terms that we'll eventually become very familiar with. But what it essentially means is, if I just add some more space here, so we got some room to think. What you can do is you can create containers without actually storing any information inside of them. And so I can go, we'll go back to the basic example with an integer. So int, and then my second integer container equals, actually, what I'm going to do here is instead of actually storing that value in here, if you look up here where we had that equal sign and then the value that was stored in it, if we leave off the last part of this here, what's going to happen is we're going to create an empty box that doesn't have a value inside of it. And this can be very useful for assigning information at later points in time, but it can also be a little bit more risky, as you've got to be aware that when you do something like this, if you try doing something with an empty container, there is no value, or there's nothing stored inside that container. So if I were to try to print out my second integer container, the one storing currently nothing, you'll actually see that Java gives me an error. And that's because there is no value within our container. Java will become happy again if we store a value inside of it. But I want to real quickly show you kind of these vocab terms. Declaring a variable is when you simply create the container, which is done by listing what type of what type of information you're going to store in that container, and then the label of that container. That is what is known as declaring. Uh, the process of storing a value within a container is something called assignment. So if I take that container, we have it labeled and everything, so we can easily find it within our computer's memory, and I want to put a value of 5, or let's go 15 this time in there. Java looks for that container and then will replace whatever is currently inside of this container with the value that we're putting inside of there. In this case, 15. And currently there is no information stored in here because we have only declared it. But it's going to store this value of 15 inside of our container here. And then when we print it out, it's going to behave like the exact same way as all of our other statements up here. But in this case, what we did is we split the process of declaring and assigning a value. This was assignment, by the way. Assignment. Oops. Assignment. Into two parts. In the statements up here, we actually just did this in a single line. We both declared, which was this part right here, and then we assigned the value right there. We can split those up into two parts, and Java's fine with that. But that whole process there of both declaring and assigning is what is called initializing a variable. So once this value finally has something stored inside of it, that is when it has become initialized, and Java becomes happy again. Alright, so that brings us to the end of our first kind of official tutorial here. If you'd like some more practice, if you go over to the File Explorer here in the Lesson 1 folder, you can take a quiz, just kind of see where you're at. To run it, you just hit Run Java on this play button up here, and you can type in any of the following data types to kind of see that you understand what each of the questions are asking. And then, in addition to that, there is also an exercise in here where you can go through this file and replace each of these triple question marks with the correct data type that would solve the problem. If you've done it correctly and you hit the play button, it should let you run the file and should give you all of these errors. So, but that's the end of this tutorial. Thank you for watching, and we'll catch you in the next one. See ya!